Okay, this is an exam question on the action of enzymes. And it says, in an investigation to the action of amylase, equal volumes of enzyme solution and starch solution were mixed. So we know amylase is involved in the hydrolysis of starch. The quantities of maltose produced was measured during the course of two separate experiments. So maltose is what amylase is breaking down starch into. One carried out 18 degrees C, the other at 23 degrees C. The results are shown in figure 4.1. And we've got the quantity of maltose produced on the left-hand side and the time along the bottom. And we've got two graphs, one carried at 18, one carried at 23. Explain why the quantity of maltose produced eventually becomes constant. So with both of these experiments, the volume of maltose, the quantity of maltose produced becomes the same amount and it's produced at a constant rate. And the question says, explain why the quantity of maltose produced eventually becomes constant. Well, there's no more maltose being produced, so the time is still continuing, but the amount of maltose is not increasing. And that's because we know the amylase breaks down starch to maltose, so the starch must have run out. So there's no starch, and that's the substrate is left. Part 2. Explain why after 4 minutes more maltose have been produced at 23 degrees C than at 18 degrees C. So if we look at the graph again. This is 23 degrees C, this is 18 degrees C, and we're looking at 4 minutes. So you can clearly see there's a larger quantity of maltose produced at 23 degrees C than at 18 degrees C. The question says, explain why after 4 minutes more maltose are being produced at 23 degrees than 18. So we've got to explain why using our science. Well, at 23 degrees C, there's more kinetic energy. Particles, not particles, sorry, we're not allowed to talk about particles. The substrate and the enzyme are moving more. They're moving more because they've got more energy. So therefore, there's more successful collisions. And that's between enzyme and substrate. Remember this from GCSE when we did about effective temperature on rates of reaction. And therefore, there's more enzyme substrate complexes formed. And if there's more enzyme substrate complexes formed, then there will be more maltose produced at 23 degrees C. Okay, the final part of this question then, it says, the experiment was repeated with the same volume and concentration of amylase, but with a higher concentration of starch. Sketch on figure 4.1 the curve you would expect to obtain if the experiment were repeated at 23 degrees C with an increased starch concentration, and this is worth 2 marks. So going back to the graph, we know we're doing it at 23 degrees C, but we've got an increased concentration of starch, therefore we've got a higher concentration on the substrate, so there'll be more enzyme substrate complexes formed because there'll be more collisions between the enzyme and the higher concentration of substrate. So the graph will be much steeper than at 23 degrees C, and that'll be the first marking point. We've also got a higher concentration of maltose, so it's not going to level off at the same rate. It'll level off much higher than 23 degrees C because we are going to make more substrate. So we've got a higher quantity of substrate produced at the end.